Hello, grade 10s. Today we start the next unit, similar triangles. Now I will say that our previous unit, the factoring one, is the hardest unit in the course. I really believe that. So if you found it difficult, don't worry. Let's just move forward. And I think you'll find that this is actually one of the easier units in the course, maybe the easiest one of all. So to start, we're just going to go over 6 different types of triangles that I'm sure you've seen before. So here I have each type of triangle as well as the definition of each one, and they're not matched up. So what I would like you to do is to match them up. So you can look at it and just try to figure out which one's which, and then when you're done, we will go to the handout and we will put the descriptions here, and then we'll draw a little diagram for each one. So please pause and just try to figure out which one's which. You can copy and paste the descriptions into here if you want. Okay? Okay, so let's go through this. So first we have an equilateral triangle. You might remember that equilateral, it means everything's the same. So this one is all the way down here. So 3 equal sides and all angles are 60 degrees. So in your definition thing for equilateral, if I can, there we go, for equilateral, you would write that in there. You would write a triangle with 3 equal sides and all angles equal to 60. And the reason they're all 60 is because if they're all the same, we know they add to 180 from grade 9 or even maybe grade 8 or 7. And if you divide 180 by 3, you get 60. Okay, a right triangle. A right triangle has a right angle or a 90-degree angle. An acute triangle, all of those angles are less than 90, so that's this one here. An obtuse triangle has one angle that's more than 90 degrees. An isosceles, this is straight across, an isosceles triangle is where we have 2 equal sides and 2 equal angles. And finally, scalene is the top one. So all 3 sides are different. And then what I have here is I have a little diagram of each one, and this should help you with your diagrams. So this is the isosceles. Okay, now I'm just going to change the font to black, just because. And then what you can do here also is we know these 2 sides are the same. That's what these little ticks mean. And then we can say these 2 angles are the same. Okay, so that's isosceles. You can draw the diagram again in here. So the diagram would go here. So you draw the isosceles triangle there. All right, next up, this one has a right angle. So this is a right triangle. Okay. All right, this one, all 3 angles are different. They're all less than 90, so this is a acute triangle. It's got all those cute little angles, so it's acute. This one's got this big angle here, so this is an obtuse triangle. And this one, I didn't say anything about the angles. We're just looking at the sides. This is obtuse, actually, but in this case, we're looking for the word scalene. So you could say this is an obtuse scalene triangle, and that would be correct. Next one, 60, 60, 60. So for this one, we would do these ticks to say that all the sides are the same, because if all the angles are the same, we know the sides must also be the same, and that's equilateral. And that's it. Okay. So here we go. It's going to be a really quick lesson today, really easy lesson. We'll start getting into the harder stuff tomorrow, but again, this stuff's, I don't think it's too difficult. So when labeling triangles, we always label a side based on the angle that is opposite. And this word opposite is going to become very important in the future. So let me show you what I mean here. So if I have triangle A, B, and C, then what we would say is that this side is little a, and across from B would be little b, and across from C would be little c. Now, some people think, like, let's look at this side here. So the side from B to C, people might want to call it BC. And that would technically be correct. That's fine. But we like to use one letter because once algebra starts coming into it, when we're solving for things, if you have multiple letters, it gets really hard to do. Some people say, oh, let's call this side B because there's a B here. But I think you can see the problem there is if we call this B, then we could also call this side B because both of these sides come from B. And so that's why, essentially what we do is we give the name of the side to the only vertex or the only corner or the only angle that's not part of it. So we label across, okay? So that's how we label the sides. It's very important. It's a very simple concept. In class, we'd spend some time practicing this, but unfortunately, we can't do that in this forum. All right, so if two triangles are similar, we say that corresponding angles, so this is the word similar. You'll see it a lot. This unit's called similar triangles. So let me show you here what similar means. So I've drawn a triangle here, and let me copy it. So these two triangles are the same, right? Because this one's a copy of this one. Now check this out. If I grow that triangle, what can you say about the angles? Well, the angles are the same, right? These angles add up to 180, these angles add up to 180, and since the sides are in the same proportion, these angles are the same. So we say that corresponding angles are equal, and we would say that corresponding sides are proportional, and that's what we're going to spend some time talking about now. Okay, so you're just filling in the blanks. Now here we go. So if triangle ABC is similar to, that's what that little squiggly line means. It's just shorter than writing triangle ABC is similar to, right? So we have this little symbol that means similar to. And this is what it means. This means that angle A equals angle D, because the first angle in each would correspond, so they're equal. Angle B would equal angle E, and angle C would equal angle F. And the easiest way is, look at this, A, B, C, D, E, F. It's just that easy. Okay, and now for the important part, and the part that's going to make this unit something worth looking at, is the sides. So this is the angle information. And then for the sides, this is what we have. If we take the ratio of little a over little d, that's going to be the same as the ratio of b over e, and that's going to be the same as the ratio of c over f. Little letters mean sides, capital letters mean angles. And let me show you how this sort of works here. So let's say we have this triangle. And I copy it. Okay, so this will be triangle A, B, C, and then this will be triangle D, E, F. So let's say that to get from this little triangle to the big one, we doubled everything. Well, this would be side little a, little b, and little c, and this would be little d, little e, and little f. So you can think, if side C doubled to F, what would side B do to get to E? Well, it would double as well. And side A would double and would become D. So all this says is that if one side doubles, they all do. And don't worry too much about it. If you can write these two things by the end of today, that's all you have to be able to do. All right, here's the last example. We're only 8.5 minutes in. The lesson's almost done. So given these triangles below, write a similarity statement. So a similarity statement looks like this. So let's take the first triangle, triangle. I'm going to start here. Usually you start at the top and you go counterclockwise. It doesn't really matter. So triangle GHS is similar to triangle. And again, if you started here and went this way, now it does matter. You have to do the same thing here. So you start at the top and you go around this way. So triangle ROX. It says GHS rocks, if you didn't notice. Even though we're not there, it's still pretty cool. All right, so again, we start here and we go that way. So we have to start here and go that way. And the only way things get tricky in this is if the triangle's rotated and or like shifted around, and then you have to figure out the order, but we'll deal with that another day. Now we got to list the ratios of corresponding sides. So it just looks like this. So remember, we do little letters. So this is going to be little h, little g, little s. Remember, I'm just going across from the angles. Little r, little o, little x. And the ratios of corresponding sides really match up to what's here. So we say g over r. So the first side here over the first side here is the same as the ratio of the second side to the second side. is the same as the ratio of the third side to the third side. And you'll notice that on top you have the first triangle, GHS, except for little letters, because little letters are used for sides. And on the bottom, you just have this triangle written again, ROX. So that's it. Like there's not much more to it. The corresponding angles, so we can say angle G equals, and I would love for you to pause and finish this if you want. So angle G equals angle R. Angle H is going to be the same as angle O. And you can even just look at the diagram and see it, right? And angle S is going to be the same as angle X. And that's it. That is the entire lesson. I have a little bit of practice for you. It's basically like the same things we just did. So if XYZ is similar to MNO, I want you to tell me what angles are the same, show me their proportional sides, and then the last one, I've given you a diagram with two triangles, and you're going to do what we just did. And that's it, folks. So it's an easy day. I'm just introducing you to the concept. Ask me questions if you're unsure, because it's really important that you understand this before we move on to what's next. All right, good luck, folks.